Now when we calculate slope, we can calculate our slope using a big triangle. Okay, so I can use this big triangle here. Okay, I can have my rise between these 2 points and my run between these 2 points. Okay, and I can have a big triangle here. I can have a smaller triangle. I can use the rise between these 2 points and the run between the same 2 points. Okay, and I'm breaking down my x, my y from my x. So we'll do it both ways. Here I can calculate my rise. I can just count on a grid. So it's if ever in doubt, counting is the most reliable thing we can do in math. So I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like it's 12 down. Okay, and I'm going to measure it from left to right, so it's going to be down like this. Now we could also calculate our change in y as the change in the 2y position. So we ended up at -4. Okay, and we're going to subtract +8. Okay, so the difference in those two coordinates is going to give us the rise. Okay, or in this case, the fall. In the denominator, we need the change in the x. So it's always a y on top, x on bottom. So the coordinates, or the distance, if I calculate, if I can just count, again, counting is reliable, 1, 2, 3, 4, 5, 6. Okay, so 6 coordinates. We can also use our formula, which is we ended at x is 0, we started at x is -6. Okay, so our run is +6. And when we work out that ratio, we can simplify that ratio of -2 to 1. Okay, so there's our slope. And we could have gotten the exact same slope by looking at the smaller triangle. The smaller triangle has a rise of, in this case, -4 compared to +2. Well, that's going to give us the same ratio of -2 to 1. So here I can, this is a horizontal line. Okay, when I think of the horizontal line, if I were to actually describe this slope, I would say that this has no slope. Okay, well, I can also calculate this slope using my slope formula, because I can see that my change in y, okay, looks like this is a little bit off. Let's just say that's right on the line. So it's going to be, the change in y is going to be -3 minus -3. Well, we know the change in y is really 0. There's no change in y. It doesn't go up. My change in x between any 2 points, okay, it doesn't really matter what my change in x is, because it's going to be 0 divided by whatever that change in x is. In this case, I can use +4 minus -6, and that gives us +10. 0 divided by anything is 0. So my slope of a horizontal line really is 0. Okay, and the numerical value makes sense, but also if I were to describe the slope of this line, I would say that it has no slope, or 0 slope. Vertical line is slightly different. Okay, this is really super steep line. Okay, so how would I describe this super steep line with slope? Well, again, I can use my slope formula, change in y over the change in x. Okay, so my change in y in this case is going to be, well, I can choose any 2 points on the line. Okay, here I happen to have chosen, okay, on the dots here, it looks like 3, 6, 8. So it's going to be +8 minus, looks like -8. Okay, so we have a rise of +16. Okay, well, I could have measured between any 2 points, because I could have had any rise, and it would still give me the same slope, because my run, my change in x is going to be, well, I started at -4 and I subtract -4, which means my run is 0. Okay, so I can see that I'm dividing by 0. Well, dividing by 0 is a problem. We can't do it. So we say that this slope is undefined. Okay, so this slope is undefined. It has a vertical slope. Okay, so undefined. Okay, so this means it has a vertical slope. We usually say that, show the sign like that, it has a vertical slope. If we were to calculate this, this is getting to be infinite slope. Okay, which is because 0 goes into 16 an infinite number of times. So we can kind of say that it also has an infinite slope. But technically we should say that it has undefined slope because we are dividing by 0, and we never can divide by 0.